Thanks everybody for coming. I'm Daniel Lebrero. I'm a technical architect at IG, and we are here today to talk about REPL-driven development. But before we get started, I have a confession to make. On my very first job, I got to work with 3 technologies that made a profound and lasting impact on my career as a developer. Those 3 technologies were Netscape, Internet Explorer 4, and Internet Explorer 5. Thanks to those 3 technologies, I decided to become a backend developer, and I have been avoiding any kind of front-end work for a lot of years. And I have been a very happy Java developer living in a world of XML and JSON. But in a recent project, I got to work with a team of front-end developers, and I have to admit that since that project, I am very, very jealous about the front-end developers. You might be thinking, why? Maybe the JavaScript that they are using is somehow different than the one that I learned 15 years ago. Not really. It has improved a little bit, but at its heart is exactly the same JavaScript. Maybe they have had enough time to fix all those incompatibilities between the different browsers that used to drive me crazy. Well, not really. They're still there. To understand why I'm so jealous about the front-end developers, let's look at a picture of myself doing some front-end work. That's me trying to get a 2-column layout working in Internet Explorer 5 or 6 and Opera. And as you can see, I'm not very good at it, and I just try and try, but at the end of the day, I always end up with the same thing. It's just a big pile of crap. But even CSF doesn't make any sense to me, there is something really nice in the picture. So let's look at it again. Focus on how Mr. Griffin is able to pull from one string and he sees straight away, without any delay, what's the effect on the blind. And if he doesn't like it, he just pulls the string in a different direction. And he just keeps doing that from one and the other until he's done. That immediate feedback is what I really, really miss on my day-to-day work. And we know from Agile, Lean, and Scrum that these feedback cycles are very, very important. And the shorter the feedback cycle, the better. But why is it so important for us developers? Well, without this really fast feedback, it's very hard to get into the flow or the zone. The flow is that state where you feel like Neo when he comes to realize that he's the chosen one. When you are in the flow, you are so focused that the real world disappears, and it's just you, your application, the code, its design, and the data flowing through it. When you are in the flow, no problem is hard enough, and no bug can hide from you. And your solutions are simple, clean, and elegant. But why we want this flow? The first thing is the productivity. When you are in the flow, it's when you are the most productive. And it's not just that you are able to produce more. What you produce is of a better quality. But this productivity is a nice side effect of being in the flow. What is really important is that feeling of joy, that feeling of achievement, that feeling of creating something really beautiful. And is this feeling why me, after 15 years, I'm still a developer? But we all know it. You are there in the flow doing your tips and tricks, and then, oh, you need to build something. And what happens? That's how little it takes to get you out of the flow. And we, middleware developers, we are expert at this, right? We even have comics about it. And we are so used to it that we think, that it's part of your job to wait for the compiler. But if we look at what usability experts say, they say that your feedback loop should be of 1 second and less, right? Without that 1 second, you are just getting out of you lose your train of thought. So when I was preparing this presentation, I created a completely new project using the company's archetype. It's just one controller with one test, and I just compiled it and started. Do you guys know how long it took to build and compile a new empty project? Does anybody want to give a guess? No. It took 30 seconds. 30 seconds to build and start a new application. Are those 30 seconds like a crazy number, or are those 30 seconds a reasonable amount of time? So let's think for 30 seconds, about 30 seconds. Okay, are we ready? Those were 30 seconds. I promise you they were 30 seconds. And I don't know how it felt for you, but for me, standing up here, those were really 30 seconds. And this is an empty application. And we do this all the time, and we think, it's okay, it's just 30 seconds. But of course, we try to avoid this thing. If you follow the advice of that very wise man, you try to not run your application at all. What you do is you do TDD or you try to write test, and you try to avoid running the application completely. But if you have been doing TDD long enough, you know that it has some shortcomings. The first one, who can tell me what mocks, fakes, stubs, and spies have in common? What are mocks? Mocks are just lies. Fakes, lies, they're all lies, right? They're things that are not real. They're things that we make to be able to have that really fast feedback loop. But I think we cannot avoid them, but what we want is things that look as real as possible. And TDD doesn't give us any tools to be able to build those credible lies. When you need, for example, to talk with a third-party service and you want to create a mock, the only way of actually being able to mock it is by just calling that third-party service, because you need to understand how it behaves before you are able to fake it, to lie about it. If you have to talk with the database, the only way to know what kind of data is going to be in the database, or the best way, is to actually just go and look in the database. So you need to write code, you need to interact with the real thing to be able to build your life. And the second thing that I found always true on TDD is that it doesn't matter how many tests you have, doesn't matter your code coverage. Once you start the application, you are always going to find some bug. Maybe your Spring configuration is wrong, or you forgot to do something, or the libraries that you are running, they don't work. There are always going to be those kind of bugs. And when you find this kind of bugs, you are again back on that really, really long cycle of building the application, starting, see if it works, you change another thing, you rebuild it, and you start it, and and it just becomes really cumbersome. So what do we want? We want to be able to write some code and immediately, without delay, see if it works and it does what we expect to do. We don't want to be building and deploying stuff. We want some help on creating those lies. We want tools. We want a way of exploring the real world, what is there, how it works. And we don't want surprises when we start the application. So of course, we're going to use a REPL for all that stuff. So REPL stands for Read-Eval-Print Loop. And we have all used a REPL, usually in the form of a command line interface, right? It's just read means that the console, in this case, is reading your command, then the command is evaluated, and the result of that evaluation is printed back. And you loop, so you have, again, the option to type another command. So this is what REPL looks like. The only difference is that instead of putting Unix commands, what we are going to be doing is sending little pieces of code. Yep. So for the demo, what we are going to do is we are going to start Maven, so your build tool. We are going to start a Tomcat inside Maven, so that's your application server. We are going to run the application inside Tomcat inside Maven, and we are going to be running our REPL inside our application. Now, instead of typing there in that little window inside your application, what we are going to do is connect that REPL with a socket, and from your IDE, we'll connect to that socket. And what we are going to do is write code there in the IDE, where you always write code, and we are going to send that code through the socket to the application. That code will run, it will be evaluated, and it will send back the result. And we'll see the result there on that window over there. Okay? Any questions? Cool. I'm going to be doing the demo in Clojure. So Clojure is a Lisp for the JVM, but the language is not important. What I want you guys to focus is on the workflow. So I want to compare what you usually do, things at work, with what we are able to do with the REPL. Okay? Now, one of the nice things about a REPL is that it actually helps you to learn a new language. It makes it easy because you are able to build your language, your knowledge a little bit at a time. So to the list of things that we want to from our workflow, from our REPL, I'm going to add another one. So let's go for it. Have you guys seen any demos so far? No? Okay. I'm going to be the idiot. Cool. So the first difference with our REPL-driven development and your usual workflow is that the very first thing that we are going to do is we are going to start the application. Yeah. So, oops. So I don't know what you guys do, when you get to the office, but what I'm doing here is just start, it's just a web application. So what we are going to build, it's a RESTful application that is going to go to the database, is going to get some records from the database, some transactions, and it's going to do a summary of those transactions. And the very first thing that we do is just start the application. The application is more or less empty. And this is the slowest bit that we are going to suffer. It takes around 30 seconds also. But this is something that you will do once a day, once a week, once a month, depending how often you update your PC. So the application is up and running. So the first thing that we are going to do from your ID, I like idea. Yeah, like that. We are connecting to the REPL. So we are going to be writing our commands here. And we are going to see the results of the REPL here. So let's learn a tiny bit of Clojure. So Clojure programs are lists, and this is how you create a list. In the case of Clojure, the first thing after the parentheses is the function that you want to run, and then you specify one or more parameters. Yeah. So this is our first Clojure program. What I'm going to do now is I'm going to send this piece of code, I'm going to send it to the REPL that's running inside the Tomcat that's running my application, and I'm going to see what's the result of evaluating that expression. Yeah, so we see it here. We send +1 and 2, and we got 3 back. Is that okay? So now it's when you will, if you are curious about the language, you will say, well, what happens if instead of 2 parameters, I specify 3 parameters to my plus function? I'm going to, again, just evaluate it. I'm using a shortcut. I evaluate this piece of code, and I get the result here back, 6. Yeah. So that calculation is being done. Remember, it's being done on the application. Cool. Let's learn a little bit more of Clojure so we can see the demo. So we are going to define a global variable with a map. So we are going to see how maps look in Clojure. So maps are with curly brackets, and you specify the key and the value, and you can specify another key, another key, and another value. Yeah, and evaluate that. Again, I have sent that thing into the application. So now we have in an application a map called M, and now we can look at what's the value of that map. So if you have here about Clojure, Clojure has immutable data structures by default. So if you want to understand what it means that if I add to this map a new item C, and I evaluate that thing, so the result of adding C to this map, we show it here. And A, B, so we have a map with 3 entries. Now, if we go and print what is the value of the existing map, the M, we see that still 1 and 2. So we still have just 2 items. Yeah? Everybody with me? Yeah, so the important thing here is just I write a little piece of code, I run it, and I see straight away what is the result. So this is what it's going to allow us to do. It's just learn a little bit about the language, play around with it. Cool. So I think that's enough, right? So what we are going to do now is build the application for real. So as I said, what we are going to do is build an application that's going to go to the database. It's going to get a bunch of transactions for a given client, and then it's going to summarize them, and it's going to expose that as an HTTP endpoint. How I will usually do that before knowing about a REPL, I will open Oracle SQL Developer or Squirrel SQL or some SQL thing to be able to go to the database and see what's in the database. But instead of that, now what I'm going to do is just from the REPL, we're going to try to connect to the database. So the very first thing, this is the JDBC URLs, if you are familiar with JDBC. And what we are going to do is first check if we can connect to with the database. If I run that, I'm getting a not suitable driver found for blah, blah, blah. So if you are familiar with Java and the JVM, we need to add a dependency. So I forgot here to add the database driver. So I will usually have to uncomment this thing, rebuild the WAR, deploy it again, and see if this driver works. But instead of that, what we can do, because the JVM is able to, just tell the JVM, oh, can you please load this dependency into your class path loader? So we have now that, and we try to run again the query. So now it's complaining. Connection to localhost refuse. Check that the host name and the port are correct. That's it. So I change that. I run it again. I forgot again something. Oops. I forgot my O, and I run it again. And now it works. So what we have done here, it's one bit at a time. Try to build your configuration. This will be the equivalent of creating a properties file and trying to get it right. But instead of having to restart the JVM every time that you get something wrong, we just can try it straight away. So that's the first thing. Now, the JDBC spec comes with a nice metaprogramming API where you can go and ask the database about which tables and which schemas do you have. So, we can just ask the database which tables you have that start with transactions, something like that, because we assume or we think that they are going to be related, and we get here the results. So this will be the equivalent on SQL Developer of going and trying to find, getting the list of tables for a given schema. Now, the nice thing about it is that if you don't like these maps, these are maps with things, you have all of the language capabilities. So if you prefer to draw it in a more table-y way, you can do that. So now that we have identified that probably this is the table that we are interested about, we can just go and do a query to see what is there. So we see that that table looks like what we want. So we have a transaction ID with the client, some kind of type, the currency of the transaction, an amount, and then some kind of timestamp. And again, just to make it, I prefer this format, so that's very clear. Now you might be wondering why we are bothering doing this thing from the REPL instead of just using a proper SQL tool. So the first reason is that, and again, if I cut this thing and I wrap it inside a function, and I get a DB and a client, and I fix this thing. Oh my god, this is very big. Okay. I'm just creating a function with the query that we just did, and I have a bug. And I fix the bug. There it is. Yeah. What is this function? This function is the first bit of production code that we have written, and we didn't have to copy from one place to another and then convert this thing into some kind of Java store protocol query parameter. Something that I made a mistake, I just fix it, and we keep working. It's something that is not completely unrelated to what you are doing. So what we are doing is building this thing one bit at a time on the REPL. Now, let's say that you have you notice here that the currency are in different. We have different currencies, and we want to translate those currencies instead of having everything, one thing in euros, another thing in GBPs. What we actually want to do is have everything in euros or in GBPs. And you know that your company has some microservice that will give you the changes for at a given time. So you can do exactly the same. You start building one bit at a time. In this case, we try to hit the endpoint. The endpoint is returning a 400, and if we look at the error, it says somewhere here that we are missing a date. So we can just go, we add a query parameter, date, and oops, we just try it again. So now we send this command to the container, the application run it, and we see that we are getting back some kind of body that looks like JSON is. So what we are going to do, it's again one bit at a time. We get the body. We see now that we are a little bit closer to what we want. We want to parse this thing. So let's parse the JSON, and now, yeah, we have a piece of code. That's the result from the application. So what we have done is, again, one bit at a time. I just write a piece of code, and I will evaluate it and see what's the result. And I will I will check again. I will run it. So we are all the time getting that really fast feedback cycle. But if you were using an SQL developer tool, probably you are also using something like Postman or some Chrome extension to make the HTTP calls. But if you want to mix the data from your DB calls with your HTTP calls, that's something that you cannot do in SQL Developer. That's something that you cannot do in your Postman. So being able to do that thing in the same place, it means that you can mix and match data from different places. Now, another thing that you cannot do in your SQL Developer or Postman is just create a simple for loop. So if we decide that we want, instead of just getting one point of data, we want several points of data, let's say we want the last 10 seconds or 20 seconds of exchange rates, we can just go and create a for loop and see if this works. No, it's because I need one more. And then we change the date for a T. Let's see. Cool. So what we have done, it's just we have made 10 or 15 HTTP calls, one with a different timestamp. So just to make sure that we have the timestamp, I'm going to add the time into the result. So what we are doing, instead of looking at documentation or trying to build classes, we are just building really small pieces of code, and we are running them all the time and validating that they are doing what we want. Now, because you are in the JVM, it means that you have all the libraries that the JVM gives you, which means that if you want to get fancy, and instead of seeing a list of data, you can use any library that you will get in the JVM. So if we want to plot the data that we got from those services, we can do it. So that's another thing that you cannot usually do if you are using your SQL Developer, Postman, whatever it is. Now, if you work for a company that uses store procs instead of being able to write your own SQL queries, you will know how painful it is to make calls to get the store procs and to get the data from them. But again, we are in the JVM. The JVM has a nice meta data programming for the JDBC, so we can do exactly the same. We can ask the JVM, the database, about which store procs are there. We can guess which one we are going to want. So in this case, it's the transactions in GPP. Once we know which one it is, we can just go and generate a little piece of code. So we get a piece of code that we can just copy and paste. We run that, and we see we're getting some results back. Now, how likely it is that my store proc definition or the HTTP calls that we were making, how likely it is that they're not going to work when we deploy them into production or into our staging environment? Well, the thing is that when we evaluate this thing in the REPL, what we are actually doing is we are deploying it. So we are all the time deploying and running things inside the application. So, I'm not going to mistype. It's impossible that this thing is wrong or that this client ID is wrong because I'm running it all the time. So we have been looking here about trying to build an understanding of the real world, going to the database, going to an HTTP service, trying to build and massage the data to see what is there. Now that we have this understanding, what I will do is change my hat and try to do a little bit of TDD. So now we know how the system is going to work. We know which data we can expect from the database. So I will change to write some tests. So I have some tests here. So let's say that we want to test that summary function that we were talking about. So to test it, I need a piece of data here, right? You need an example of a list of transactions that we are going to get from the database. What I will usually do is, well, you need to create your mock data, you need to type all that thing. But if you think about it, well, here we have a good example, right? And this example comes directly from the database. So I can just do that. How likely it is that my data or my column names or these things are coming from the database? So the lie that I'm creating right now, it's a real lie. It's something that we are seeing that is happening in our test or staging environment. So I will run the test. I'm now running the test, so let's run it. Yep. So I'm going to go through that cycle of TDD. So we have our first test that is passing, and let's say now that we want to ignore transactions that are of type 101. We just want to keep the ones that are of type 100. So because we are doing TDD, if we do the calculation, we know that this thing, instead of being 42, is actually 18. Yeah, I run my test, and it's failing. So now that I have a failing test, I can actually go and fix my code. So let's fix our code. I evaluate this, I run it, and I run it again. Cool, is passing. Yeah, so we are into that cycle of I write a broken test, I go and fix it. Now, it's interesting to know that these tests are actually running inside the Tomcat, right, in your application, which means that, again, it's a little bit more realistic. They're in a little bit more realistic environment. But let's say now that instead of just ignoring the types, the type 101, we also want to ignore any amount that is negative. Yeah, so we will change again our test, and now we expect a 23. If I run this, it breaks. Now I have to change to this window, and I want to remove it. But having to change from one window to another, it's a little bit cumbersome. So instead of doing that, what we can do is tell our application to keep track of which files you have been changing. And what it's going to do, as soon as you change one file, it will run the test related to that file. So if I now remove that and I save it, straight away, without having to switch from one window to another, it just runs, you get a result. So in this case, I just make a mistake here. Instead of filter, is remove. And if I save it, it runs. Yep. So I don't need to be changing things, changing windows. The REPL is just going to take care of running the test for you. And the nice thing, apart from that, is that if I make a change on a file that is completely unrelated to any, it doesn't have any test, and I save that, it's not going to run anything because I make a change on a file that it has nothing to do. It doesn't have any test. Now if I change again, just to check it, I change this file that has test, it will run those tests. So it's not just running all the tests, it's just running the pieces of code, the tests that actually can affect, that are affected by your change. Okay? Cool. So we have seen how a REPL can help you first to create the fake data that you want to use, and second, it's going to take care of running just the bits, the tests that are actually can be affected by changes on your while you are working. So we have something more or less working, and what I will do now, it's okay. Now we need to go and change. Well, now we have all the pieces ready, so what we want to do is just create that HTTP endpoint for us to actually go and hit it. So the application, it's exposing as Swagger UI. I don't know if you have seen it, but it's just basically a way of telling you, showing you which endpoints are in the application and allowing you to play with them. So right now we just have one endpoint, that is the ping endpoint. So what we are going to do is just add another endpoint. So to do that, we just copy and paste a little bit of code. We change that into total. We say that we expect as a parameter a client that is of type long. Let's see if that works. So refresh this. And here we have our total. Yep. I'm going to test it. Still returning the old thing. Yep, so that's how long it took me to create a new endpoint and get some feedback about if the endpoint looks or feels like what we expected. Now what I'm going to do is just end up my wiring. The other way around. So we get a database, and we are going to call the code that we just created. So DB total transactions, DB and client. Cool. So if we try it again, it didn't work. That's because I got it the other way around. Oops. If we try it again, there it is. Yeah. So we have all of our wiring right now done. Yeah, we don't have to be mucking around with XML files or restarting every time that you want to change the wiring. And as you saw, I made a mistake. And it's very simple. You just change it, see if it works, and that's it. Now let's say that apart from returning the total, we want to also return the client that was requested. So I change it here, I try it again, and I get here the client ID. Now instead of client, we actually just wanted to call it C. But changing again between these two windows is getting a little bit annoying, right? But we are on the JVM, and the JVM is able to make HTTP calls, right? So we can just add a little piece of code in our REPL just to make calls as soon as we make a change. So we see here the result. So instead of C, I'm going to change it back again to client. And straight away, we see the changes as soon as we save the file. Yep. So, you know, we are developers, we are making HTTP calls all day long, but then for some strange reason, when we have to make an HTTP call to test our code, we just go and use a different tool for it. And this way, we are getting a really fast feedback. Now, we have this refresh and everything reloads, so what happens with the state of the application. Yeah? What happens if we have, for example, a counter and we want to increment the counter every time that somebody makes a call. So if we see there, we have a counter of 1. I'm going to make a bunch of requests, 2, 3, 4, 6, 7. And now if I make a change, let's say that instead of counter, we want to call it count. Our state has been reset. So if this was a database connection pool or some cache or something, it will be very annoying that every time that you make a small change, you have to go and reload everything from the database. Okay? This is a problem that, for example, the JavaScript guys with single page applications, they have like, you make a small change and then you hit F5 and then you are losing all your state. So instead of that, what we can tell the REPL is, well, this particular piece of state, please don't refresh it. So we're going to tell him not to refresh it every time that there is a whole refresh, not to reset it. So if we go back to our count, we see 7, now it's 8, now is 9. So now the state it's not reset. So we are controlling when, or we are controlling that we don't want that state to be refreshed. But it's not just a matter that we can use that state. It's just if we want from the REPL directly, we can go and look inside to see what is in there. And if we want to change it, we can go and change it directly. Let's say that we wanted to test a case where the counter number was very, very big. So we'll just, you can put whatever data you want there. And then just make your HTTP calls and you have the data or in the state that you wanted. And of course, if for whatever reason you actually want to reset everything, you want to destroy all your state and start again, there's a small function that you call it again, and you will start again from scratch. So we are able to control exactly the state that the application. We can change it whenever we want, we can inspect it, and we can reset it. Cool. So we saw how we were able to play with the language one bit at a time, and we will be able to do the same with any kind of library. We were writing little pieces of code, and straight away we were able to see exactly what we got from that. We have to build once and deploy once, but on practice you will do that like once a week or something like that. We were using the data straight away from our interactions with the database or with the HTTP service to actually being able to feed them into our test. We have all the Java libraries in the world to go and poke into GMS services, into databases, into Kafka, into Hadoop. You have, Java has libraries for absolutely everything. I'm not going to say that you're not going to get any surprises, but you are going to get fewer surprises when starting your application. We saw that we were able to add new libraries to a running application instead of having to restart it. Our TDD workflow, it's a little bit easier because it will just run the test that can be affected by a given change. And we saw how we were able to manage and inspect the state. And we were doing all this from the IDE. Now, if you think about it, we are connecting to an application just through a socket, which means that there is no reason to run this thing locally. What will happen if you run a REPL on your applications, on your staging and production environments, and then from your IDE, you will connect to those applications? How many times you have put some code in production, and then one of the QAs raises a bug, and you say, well, if I could just look at what's the state of that cache, or if I could just look at what's the state of that Java bean, that particular number, I will know straight away what's the issue. Or if I could just go and change one line of code, one login statement, because I forgot or I didn't expect to need this particular login in my application. With a REPL, you will just make the change on your IDE, and you do as you always do. You will hit one stroke, and it will be straight away in staging, instead of having to change something, redeploy it, and all the stuff. But who will be so crazy and wanted to do this thing in production?
I actually did.
So the NASA, 1999, debug and fix, and by fix it means that they make a change on their code on a spacecraft that was 100 million kilometers away. Yeah, so that's something that you cannot just, do very often. So apart from the things that we said, we want to be able to debug and fix our staging and production environments if it's really, really necessary. And we want to be able to control spacecrafts. Just remember why we want this thing. Just 30 seconds. Just 30 seconds. Just 30 seconds. Yeah, it's that joy, productivity that you get when you are in the zone, when you don't have these interruptions. It's not specific to Clojure. There is a bunch of other languages and platforms where you can do it. This is the code I have been using during the talk. And I invite everybody to look at that first presentation by Brett Victor, Inventing by Principle. It's just amazing. And it has a lot of this, why you want to have that immediate feedback. It will change the way you look at programming. And with that, I'm done. Any questions?
How much of that are we getting in the REPL that's coming in Java 9? If you have any ideas.
So this is my reaction when I saw the REPL on the Java 9. So that's basically. So the Java 9 REPL, what they said, the objective is to make it easy to learn the language. So you are going to get just the very first feature, that to be able to run a little piece of code in a shell and evaluate it, and you will get something out of it, to see how it's going to work. But they decide that it's just too complex to put into Java most of this dynamic, because you need to have some dynamism to be able to reevaluate things, change how things look in memory and all that kind of stuff. So I think they just said, oh, we're going to make it at least easy to learn the language. More questions?
Does this work with, for example, Groovy?
There is a presentation on Groovy about how they do it. You are able to do it with Groovy. I saw the presentation and they were doing something slightly different, because they will have a special window where you will write your Groovy code. And for some reason, I understood that you couldn't have a piece of code that was bigger than 200 lines of code for whatever reason. Here, we are writing the code. It's not on a special place. It's just on the, where you write your production code. You don't have a special window where then you need to copy and paste. But the Groovy, I have seen a demo, and you can get most of it. You will get problems with class reloading if you are changing things, but you are able to get a lot of, a quite similar workflow.
You need to restart your server here if you import your library, for example.
And here we haven't restarted anything in the whole presentation. I have added a Postgres database, a Postgres driver. I have added the libraries to do the graphing. All that thing is important. You don't need to restart. The JVM knows how to get things from the internet and loading them and everything, so you don't need to do anything. Now, it's possible that when you load that, if you want to change the version of a library, then you actually need to stop the JVM and start it again. But just to get new libraries, there is no need to restart anything. More questions? Nope. Thank you very much, guys.